Okay, so good morning. As I told you, let me just take some examples from the book. So let me just remind you what we did before. Might be a good idea. Okay, so the title of the lesson is still integrals. Okay, so the last thing we talked about, now we just, this is extremely important. This is really what you need to know for the exam. So if you want to calculate an integral, AB f of x dx, then what you are supposed to do you remember? This function is called integrand. You ask yourself about a primitive function of that. So let us say that one is capital F. And then you write that capital F of x, and then you put this vertical line in front, and then write A to B. This is just a piece of notation. Whenever you see this, it means put this upper number instead of x. Do the same thing with the lower bound, and subtract. Yes? So that is actually, in principle, important. And there are two types of problems when it comes to integrals. So at this level, you have to be very good in calculating them. So you just see the symbol of integral, so it is clear that you have to do the calculation. You have to calculate an integral. But sometimes they ask you to find an area, or I don't know, we will see some applications later. So they might ask you something, a question that you need to understand. You have to solve it through an integral. So those are harder questions. But if you just see the integral sign and you are supposed to calculate, of course, then it is not, at least, I'm not saying that is easy, it might be very hard even, but not at this level, of course. But then at least it is clear, you have to compute something, yes? Okay, so let us focus on the second type of problems that you are supposed to calculate an integral. Okay, and I will pick some problems from the book. Let me start with a very simple one. It is problem 44. Part B, I will start first. Yes. So they have asked you to calculate integral from minus 1 to 0. 1 minus e to power minus x dx. Okay, so you're supposed to compute this integral. Okay, if you want to do this, the first question that you need to ask yourself is, this is your integrand, what is a primitive function? And I told you, a primitive function is enough. You don't need to be concerned about putting that constant c at the end. Because if you do, that constant c will appear in the first calculation, it also appears in the second calculation, and they will subtract it from each other and they will be gone. So you really don't need to pay attention about all possible primitive functions. Just one of them is enough for you. So you need to ask yourself, and this is important that you haven't forgotten the starting lesson of this chapter. Yes?
Would one primitive function be x plus e to the power of minus x?
Yes, exactly. So you need to find a primitive function, and there we learn that if there is a subtraction between them, I can do them separately. So you ask yourself, what is a primitive function for 1? If you don't remember, I really want you to remember these simple things, but you can refer to the table. So a primitive function for 1 is x, why? Because the derivative of x is 1. And a primitive function for e to power minus x, let me remind you, so if you have e to power kx, if this is your f, the primitive function is 1 over k e to power kx. But what is playing the role of k in this problem? It's minus 1. So it becomes minus 1 over k e to the power of kx. And this is important. When you have done the primitive part, you really have to remove the integral sign. I have seen students still put this integral sign here. That is completely wrong. So you have to write this vertical line in front and write from minus 1 to 0. Yes? Okay, so let me simplify this before continuing. Minus 1, so it becomes, as Maximilian mentioned, it is e plus e to power minus x. And then if you just directly write this, even it is better. And then my experience is that is just go to up and down, so put 0 instead of x everywhere and calculate it. And then put minus 1 instead of x everywhere and simplify it or calculate it. Yes? And then go back to horizontal line by writing what you got above minus the whole thing that you got below. I hope this will prevent you with messing up the minus signs. I have seen many students know what they are doing, but sometimes they mess up the minus signs. So this hopefully prevents you from messing up the minus signs. Okay, and then you open the pair of brackets, so it becomes 1 plus 1 minus e, which answer is 2 minus e. If they ask you this, you have to stop there. If they ask you to calculate approximately, then of course you put this number in your calculator with the Euler number on your calculator, you get some approximate values. Yes? And then it is important to not put any unit for it. Remember, integral is a pure number. Unless you are using it for calculating a physical or geometrical quantity. In that case, you have to put the units. So is that clear? Okay. Now let us go to another problem. And then if you remember, I told you that. So can you answer this question? That is one of those parts in the activity. If I write this integral for you, what is the answer? For example, let me write a minus e to power minus a, and then I write dA. What's the answer to this integral? Yes?
Isn't it just the same as that
It's
one?
the same thing. Because I told you that it doesn't matter which variable name you use for writing your integral. Yes? So I have, this is a little bit strange, but it is possible. When I write dA, I am emphasizing that a is my variable. And then this is the same function. Oh, sorry. Yeah, I messed up. So that is 1. I have to keep exactly the same thing. Yes? So this, if I ask you what is the answer to this, you will immediately answer it is 2 minus e. The value of the integral is independent of the name of the variable that you use. Yes? And that is what? And that is called a dummy variable. A dummy variable. Okay? So for example, if I ask you what is this one, but of course, this is usually a very strange letter to choose. Usually x and t are chosen, but that's exactly the same number. So this is important to understand. If you replace the name of the variable of integral everywhere to another variable, then the answer doesn't change. For example, let me test your understanding. Here, what do you think if I ask you this question? Let us see how many of you can answer this one. I go from -1 to 0. But I would write 1 minus e to power minus t, and then I write dx. Okay, in that case, what I'm supposed to do?
Then the primitive function of the x, I mean, it's the constant.
It's a constant, that's important. So when I say dx, I mean that I am emphasizing that x is variable. So whatever appears, this is important by the way, whatever appears here, any other letter is considered to be a constant. If t is considered to be a constant, minus t is a constant, e to power a constant is constant. So this is a constant. If I ask you what is a primitive function for 2, you will say 2x. If I ask you what's the primitive function for 3, you will say 3x. So if I ask you what is a primitive function for this constant, you would say this multiplied by x. So this becomes 1 minus e to power minus t times x. And then you write minus 1 to 0. Understandable? Okay, and then, again, don't get confused. I have to replace my variable with these numbers. So I go here. I don't touch the t part. But instead of every x, I put 0. Of course, 0 times everything is 0. And then instead of x, I put minus 1. And if I multiply minus 1, the second one becomes positive. The first one becomes negative. And then, as usual, I go back to horizontal line. I write the number above minus the total number below. And then I, of course, multiply this negative sign in. Again, it becomes e to the 1 e to the power of minus t. So I would recommend you to understand. So it's important to understand. This is one of those activities with different, of course, functions and things like that. But the idea is the same. So now we can have give two roles to this dx. One role was actually what we started. You can imagine this is a very small change in x. So with bigger ones, we usually write delta x. But when delta x becomes very, very small, you can assume that we change the name of delta x to dx. So that is important to know at the end of the day. It's a length, but a very, very small length. Okay? Or it's a very small quantity. It's a very small, it's not good to say length, because of course if it's the x-axis, the length, but if I have whatever I have here, this is the small amount of the quantity that you see here. That's the mean. But another role that we give to this dx tells us which variable is which letter is the variable if you have more than one letter in your function. Yes? That's the two roles that we have to pick. Okay, now let us solve another problem. So this is also a good question. It's a simple question, but let us do it. So it is problem 4045. They have asked you find a so that the integral from a to 2 of this function x plus 1 dx becomes 0. In principle, might be you should, without solving, you should be able to also answer that somehow. I don't recommend you without solving it, because I think one of the answers is 2.
Yeah.
Yes, because if I choose a2, then the interpretation of integral as a geometrical object is the area below the curve. So you have this curve. Of course, this is not a curve. That's a straight line. And then, I don't know, for example, something like this. You are interested from... that's also very interesting. So one possibility is this. If I draw this line, this becomes this line, minus 1 and 1. And then 2 is somewhere here. And a is a number that I don't know. For example, if a is here, this integral shows me this area. And this is clear. It cannot be equal to 0. It is something, yes, because there is some area there. But you might say that, okay, there are no numbers. Do you think there are some numbers that I can make this 0? So do you understand what I mean? If I ask you what is the interpretation of this integral, you will tell me that is the area below this line from a to 2. Okay, so I drew this line for you. 2 is fixed. I don't have any problems with 2. But a is not given yet. So it can be any number. Now my question is that, if I give you the opportunity to change a to any number that you like, where do you choose a to make the whole integral to be 0? Yes?
2.
2 is clear. Because if I do not stand on 2, if I stand somewhere here, then what happens? Then I will get this area. But this area is clearly not 0. But is there any other point? Yes?
Minus 1. Or
No, if you are thinking about -1, that has nothing to do here.
okay.
Yes, but might be -1 is true as well. I don't know. But that is a very important question. By the way, I want to teach you something else using this example as an excuse. Because having a to be 2 is clear. And then, do you think there is something else? You might think that, okay, let us think intuitively. If I change it here, I am making the area even bigger. Okay, what?
If you change a to the x coordinate minus, then we will have a balance. We have a negative area and then a positive area.
Yes, that is what I want to teach actually. We haven't talked about negative areas and things like that. Okay, that's important. But first of all, let us solve this problem, because that problem is not complicated. You just do it. So how should we do that? Usually, this number is given, and we are supposed to calculate this integral. But this problem is the other way around. This integral is already calculated. You are supposed to find this limit. But that's the same idea. You find a primitive function for this. A primitive function for x is x squared over 2. A primitive function for 1 is x. But you know that this integral is not just this. You have to calculate it from a to 2. But you know that at the end, the answer is supposed to be 0. So you have to fine-tune this a so that the answer becomes 0. And now, what you know how to calculate this. So you just expand it into 2 parts. I replace every appearance of x with 2. So it becomes 1, 2 to the power of 2 plus 2. So it becomes 2 plus 2, 4. And I put a. So it becomes 1 over 2a squared plus a. And then I go back to horizontal line. I need to write the number above 4 minus the total expression here. Yes? So if I ask you what is the expression, for what is this integral, on the one hand, it is given to be 0. On the other hand, when I calculate it, it becomes this number. So these two numbers should match. Yes? So then it means that this number should be 0. So I want to fine-tune this a, so that the whole expression, which is the value of this integral, turns out to be 0. So let us see how we can do that. Yes? So this is the question. 4 minus 1 over 2a squared plus a is equal to 0. So I open it. And then I want to get rid of fractions, so let me multiply everything by minus 2. It becomes positive a squared. This becomes positive 2a, and then this becomes negative 8 is equal to 0. Okay, and then you see there are 2 answers. One probably we were able to predict, and we will see definitely one of the values will be 2. This is a quadratic equation. I have to solve the quadratic equation. But the unknown is a rather than x. But this is b minus b plus or minus the square root of b squared, which is 4, minus 4, this coefficient times that coefficient, it becomes 32, divided by 2 times this coefficient, which is 2. But 4 plus 32 is 36, so it becomes 6. And then I will have 2 answers. So one answer, by the way, why we couldn't get even 2? Am I making a mistake somewhere? Ah, yes, that's correct. So minus 2 plus 6 is 4. 4 divided by 2, as we predicted, is 2. And the other one is minus 2 minus 6 divided by 2 is minus 4, which we were not able to predict. And the reason is clear, because I didn't teach you. Okay? Now I want to use this as an excuse to at least to tell you something. So I would say that this is OR. So the question is a E-level question. Now, I don't know, I would say this is a little bit above E-level, yes? Because E-level usually means straightforward. Give you the integral calculate. But this is, the integral is given, A is wanted, okay? But let me try to understand it a little bit better when I go back to this picture. So if you don't mind, let me just draw it better. So here you have this coordinate system. The function that you have is actually, everyone knows that this is a line, the k value is 1, the m value is also 1. If I want to draw them, for example, if I put x equals to 0, y becomes 1. And when I put x equals to minus 1, y becomes 0. So these are the 2 points, exactly as I did before. So this is your line. And then at this point is 1 and 2. And of course, if I give 2 to it, it becomes 3 here. But that's probably not that important here. And this is 2. Okay. So I think everyone agrees that we were able to predict that A2 is one answer. Yes? So A2 is one answer because A is somewhere here, and then if I move it exactly to 2, then there is no area left. It means area is 0. But one thing that we got from here is minus 4 as well. And then this one is minus 1. So if I want to show where minus 4 is, I have to go one more. It's minus 2, minus 3, and minus 4. Yes? So, and then, okay, let me continue this a little bit. So this is minus 4. It's a little bit messed up. I want to clean this. But you know the answer. So minus 4, you want to understand why minus 4 is also accepted. So you see here, if I ask you what is this height, by the way, can you tell me? What is this height? It's 3 because I put 2 here. 2 plus 1 is 3, so that's the height. So what is the height here?
Minus 3.
No, the height is again 3, but of course, when I say height cannot be negative.
Sure.
But you are right, the y value is minus 3, because if I put minus 4 here, it's 4. But the height is minus. So it means that this triangle that you see here is a right angle triangle. And this triangle that you see here is also a right angle triangle. Yes? And if I ask you what is this height, you told me it is 3. If I ask you what is this height, that is 3. If I ask you what is this length, from minus 1 to minus 4 is also 3 units. I'm talking about the length. And from minus 1 to 2 is also 3 units. So these two triangles are exactly congruent, yes? So it means that the areas are the same. And this is important. The areas that are above the x-axis are positive of the integral. So if I ask you to calculate this area from A to B, this area, I want you to write this somewhere. So this area is equal to exactly the integral. Yes? And then, if I ask you, what is this area? So assume that now your function is below the x-axis, from A to B. And if I ask you the same question here, if you calculate this, if you say that, okay, the area is the integral of f of x dx, then of course this is not true. Because I want you to convince me why this integral should turn out to be a negative number. And if this is a negative number, at least it is clear it cannot be area, because area should be positive. But how do you feel without doing anything? Because I didn't give you the function. I just draw some very sketchy picture and I told you that, okay, assume that the function is below the x-axis. I guarantee you, if you calculate this integral for this function, which lies below the x-axis everywhere, between a and b, it turns out to be a negative number. Why do you think it should be a negative number? Yes? You want to say something? Yeah? No? You?
Maybe because it's like decreasing, like...
No, it doesn't depend. It might be below, it goes up. If you are interested in a portion of area, which that area lies below the x-axis, regardless of how the function is behaving there, the integral turns out to be negative. Yes?
when you calculated, since the portion has a negative y value, and the area or the integral is calculated with the help of that, it always becomes negative.
With the help of what? Can you mention explicitly?
Well, with since it calculates the function when you put in the x value, it gives you a y value.
Yes, but where you can see the effect of putting the function in? Because this is the way that I know, this is impression. Many people think that integrals are areas. No, we started with the concept of area to motivate why we are interested in such a notion in the first place. And then I gave you another example from physics. So those examples just motivated us that the notion of integral is important. But then when we realize the notion of integral is important, the definition of integral is not neither the area, nor the velocity, nor the distance. The definition of an integral is an abstract object, is what is defined as a limit. That limit is the integral, not the area. Sometimes it turns out to be the value of the integral coincides with the value of an area. In those cases, that is an extremely important tool in our hand, useful, because we can use to calculate the area. Don't get confused. Integral is a mathematical object abstract in your head. Yes, this is important. So, but the definition of integral is this. Do you remember? The limit of sigma f of xk delta x, and then k goes from 1 to n, and of course you send to n to infinity. Yes? Now look, if I consider this function here, f of x, and then I go from a to b, if I ask you to calculate the integral for this function that you see the graph, you have to use this definition. Okay? This definition turns out to be hard. So, but it doesn't mean that we have to ignore that, because that's the meaning of an integral. But if I go back here, this is a sum. Delta x is always positive. Why? Because delta x was b, the final number, minus the left number divided by n. So what the number on the right minus the number on the left is always positive, and then you divide it by n, delta x is positive. Okay, but this f of x, in this case that I am interested in, the values for f of x for any point that you see here is what? Negative. So each f of xk in this form is negative. It is multiplied by a positive number. So for this function, the whole expression that you see here is a negative. And then you are adding negative numbers to each other. So it turns out to be negative, and then you are making a limit, making these numbers big, the number of these numbers bigger and bigger. So it means that at the end you will end up with a negative number. So this is completely expectable that the integral for this case is negative. But now my question is that, should we really completely throw the notion of integral in this case away? We say that, okay, because the integral is negative, we cannot use it for calculating this area, or we can find a way out of it. Because if we can find a way out of it, it would be very good. Because still we can calculate these areas, but we need to understand it better. So what is your opinion about it? Now my question is that, everyone knows that this integral for that function from a to b is negative. But if I ask you to calculate this area is not negative. Now the question is that, is there any relation with this area and this integral in this case? Because there was a very nice relation between the area and the integral if this part was above the x-axis. What was the relation? They are exactly equal. But now we want to explore, is there any connection between this area and the notion of integral again? It is clear in this case, we cannot say they are equal. Yes? But can we say more?
It's a negative.
Okay, but we need to motivate ourselves why this is the case.
Because Okay, when we want to calculate the area, then we need a length and height. Height.
Height.
Yeah, height. And then height and the length is the same thing here. But the f of x is negative.
Okay.
I mean, it's a negative at the height that we have. Height.
Yeah.
And,
I remember I was remembering in that way to remember the spelling. That is not completely wrong, but let me tell you a different story, okay? That's correct actually what you said. But let me ask you some question. Let me give you a function. Let me just so let me make. I have this function here. F of y is equal to f of x. Yes, this function. Can you help me or tell me, because it is not possible, I have to be very precise. If I multiply my function by a negative sign, yes, and call it a new function g of x, and I ask you to draw the graph of this function, how do you draw it?
The same way.
No, I'm multiplying the function by a negative sign. Do you think it will remain the same? Yes?
Maybe you draw it above the x-axis?
That's correct, but better. So just randomly draw something here.
No, you flip it.
So you should say, you flip it about the x-axis, so it becomes the mirror image of that one, yes? So let us see what happens. So if I ask you to draw, of course I cannot be very precise in drawing, but so what you see is something like that, yes? I am crazy to draw something hard. But anyway, so something like that. So y is minus g of x. Minus f of x. Yes? And then let us concentrate from A to B. And then from A to B here. I gave you two areas. Area number 1, area number 2. Yes? But we are very far away from area 51. Yes? So area number 1, area number 2. What I am asking you is that, what is the connection between area 1 and area 2? Do you think this is correct? I'll just flip that one. So the area 1 and area 2 are the same. So if I can calculate area 1 instead of area 2, I also know area 2. But can I calculate area 1? Yes, exactly using integrals. So how can I calculate? I would say that the area 1 is the integral, what? From A to B, but for this function, not this function. So it becomes minus f of x dx. Yes? And if I ask you what is the primitive function for the negative of the function, you would say that that is negative of the primitive function. Yes? So area 1 is negative of this integral. But area 2 is equal to area 1. So area 2 is also negative of that integral. So remember this as a rule of thumb. If you are interested to interpret integral as the area, if that part is above the x-axis, the area and the integral are exactly the same numbers. But if the area that you are interested in is below the x-axis, the area and the integral are not exactly the same, they are opposite of each other. But still we can use it, yes? We calculate the integral, whatever I get, I multiply it by a negative sign, then it will give me the area back. So if you want to have it, and I think it's extremely important to have this idea. So if I tell you, what is the integral from, so let me just draw this picture. So you can just draw it somewhere for yourself. If that is A, this is A to B, y is equal to f of x. So this area is exactly equal to this. But if you draw this picture, for example, if this is y equals to f of x, and this is from A, this is from B, and this is A, this area is not exactly equal to the integral, it's negative of the integral. But still, we can use the integral to calculate this area. But you have to respect the difference. Okay, now if you see here, when you calculate the integral from -4 to 2, what happens? You are considering two parts, but because they are of the same size, but one of them is below, the other one is above. If I ask you what is the total area, area doesn't care about negative signs. So what is the total area? 3 times 3 divided by 2 is this area of this triangle. The area of that triangle is 3 times 3 divided by 2, and then I add them, it becomes 9. So if I ask you what is the total area of the region that I hatched, you would say 9 square, what is that? Area units. But if I ask you what is the integral from -4 to 2, integral doesn't care about areas. It takes the integral for the function from here to here and from here to here. But for this one, it gets -9/2 for this part. That is the minus of the area. But for this part, it will get +9/2. And when you add them, they will cancel out. So that is why that is also possible. So remember, so we use this very simple problem to understand a little bit more about integrals. Is that clear? Okay. So remember that this is the case. So if you want, I can also add the third picture here for you. So if I ask you, so in this case, the integral is the area. If I am interested in the integral itself, you multiply by minus sign. Integral is not the area, it's the negative of the area. If I have a combination of these situations, for example, let us have something like this, and I go from A to B. Yes? This part, assume that this area is A1, this area is A2. When I say area, it cannot be negative. And let us assume that this area is A3. And I ask you to calculate the integral of this function, which I call it f of x, from A to B. Okay? So don't get confused here. So this area, this integral, is not the total area. So it is the area number 1 with positive sign because it lies above. It is area 3 with positive sign because it also lies above. But this will contribute with a negative sign. Yes? So this integral, if I ask you what is the integral from A to B, if I give you these areas, if you mistakenly add all of them, that is wrong. You have to add these ones, but you need to subtract the third one. If I ask you, is this the total area? No, of course not. And I don't tell you that integral gives you areas. Sometimes integrals can be interpreted as areas. You need to understand that. Is this integral the total area? No. But what is this integral? This is this one. If you want the total area, you have, of course, to add the areas, not to add these two and subtract the third. So I want you to understand the differences between integrals and areas. They are very connected, but they are not the same things. Yes? Yes.
But also, if integrals aren't there to show us the area, then what do they do?
If they are not there to do this,
To show us the area or
no,
determine
integrals
the area.
can do a lot of things rather than areas. Yes? For example, I gave you another example from physics. So in that one, integral helped me to calculate the distance traveled by a particle whose velocity is changing over time. That is not related to the area at all. That's still related to the distance traveled. And then, of course, I don't know. For example, if you have in electrodynamics, for example, in electricity, so if you have a static charge, so if you know this charge is Q1, this charge is Q2, if I ask, for example, let us consider both of them are positive, so they repel each other. So if I ask you what is the force between them, that's the Coulomb law.
Yeah.
Yes? But now, let us keep this a point charge, but let me make this charge bigger. Okay, for example, let me have a sphere and drop some charge on the sphere. And then you cannot use the Coulomb law probably again, or you put it on the rectangle. So what you do, you start dividing the sphere to very, very small pieces so that you can calculate the force between that very small electric charge and this one. and then you start adding them up. Then it means that you have to use integral again. So the applicability of integrals are actually quite diverse. So that is one application that you can calculate. You can also calculate volumes. Many things you can calculate using integrals. But this is important. If I ask you when, as a rule of thumb, you need integrals, you need to know. Whenever you want to do some process like that, adding these kind of terms, a function multiplied by a small change added up. Whenever you need to do something like this, you need to remember the notion of integral. Is that clear? That is extremely important. Even though this formula was not that very helpful, but still this is the core meaning of an integral. Because otherwise, if you see this, you know what to do. But the point is not this. The point is that when you need integral in the first place, and Newton's formula will not answer you this. Answers you this question, that if you have an integral, how to calculate it easier. But it doesn't tell you when you need integral. When you need integral comes from the definition of an integral. Yes.
Is it when you like have a graph and you want to see like the rate of change?
No, the rate of change is derivative.
Oh yeah.
No, I mean, for example, let me tell you something. For example, assume that you have a cable, okay, with fixed density. So I give you, this is let me make it 1 meter. And I would say that the density, so this is a line density, okay, I would say that every meter of this cable is 1 kilogram. So it's very heavy one, okay. I just keep the numbers, okay. So if I have 1 meter of this cable, the mass is 1 kilogram. If I have 2 meters, what will be the mass? 2 kilograms, okay? But this is the case if my cable is really homogeneous, okay? But might be some parts is made of different, I don't know, alloys or something. So, not alloys, is that alloy?
What do you mean?
The English, okay, it's a mixture of different metals.
Yeah, it's alloy.
Yeah.
It's alloy, okay. So might be they don't have the same density. So in that case, the density, if I call it rho, is not constant, okay? The density might differ from point to point.
Yeah.
Okay? But then the question is still clear. What is the total mass? So what do you understand what I mean? So if the density is constant, for example, 1 kilogram per meter, if that density is constant all over this cable, yes? And if I have 2 meters of that cable, if I ask you what is the mass, you say 2 kilograms. If I have 3 meters, you will multiply and that. But if the density is not a fixed number, it changes over this length. Then I ask you the same question. You cannot just multiply numbers. Do you understand? So, for example, I say that the density, if this is x, is, I don't know. So let us say 2x. So what does it mean? It means that as I go forward, that part becomes heavier. Yes, if x is large, so the density of the cable here and the density of the cable here are different. Yes, because this depends on x. And now if I ask you the same question, what is your answer? What is the mass? At the end, you should give me an answer. Because there is a mass, there is a number for the mass, so we should be able to calculate it. But how we calculate that? We say that let me chop this cable into very small pieces. Okay? So small that I can assume that the density over that small region is constant. Is that clear? And then if I ask, and then let me call this one dx. If I ask you, can you tell me the value of the mass for only this very, very small part? Then you would say approximately yes, because this is so small and the density depends on x, but because the variation in x is not so big, I cannot expect a very big variation in rho. So it means that I can take it as row x, whatever here is x, and then you multiply it by this. This will not give you the mass of the whole object, it gives you approximately the mass of this tiny bit. Okay? And then what you do for finding the total mass, you have to add them. And then this is an approximation. The approximation becomes better and better if you send the number of partitions to infinity, yes? N goes to infinity. So you see, that is more or less the same limit process. So it means that integral is also involved here. So whenever you want to add these type of sums, when the number of terms goes to infinity, you need to remind yourself about an integral. And after that, Newton's formula will help you to do it easier, rather than using this formula. Yes? But that is important because it is very important to realize when we can use integrals. Yes? Whenever you need to calculate this limit, you need to use integral. Is that right? Okay, so I will stop here actually. I do not continue more. I have already updated the Google Classroom. I recommend you to go and work on them. There are some good problems, yes. That part I want you to learn, but of course I don't think even in national exam it would be important because you will not be able to use the GeoGebra. But you have to probably know how to use your calculators to calculate integrals. And then there are some manuals for yourself because calculator to calculator is different. But don't worry about that part, at least for the time being. Focus on learning this. Thank you.